Hello there, and welcome to this quick introductory video on integration. Integration is the inverse of differentiation. You can use integration to find the area under a graph of a function fx between 2 points a and b. If we have an axis here, let me draw a function, and I'll label this function fx. Say I had a point I'm going to label this point A. Now a second point, which I will label point B. Usually to find the area under this graph, most people would draw a line between A and B. Once you've drawn the line, you would usually find the area of this regular shape. However, it's not quite accurate. As you can see from here, you'll have an underestimation as there is some part of the function that is above the line. Essentially what integration is this process, except the width of the area is very, very small. In fact, the width is dx, infinitesimally small. And what it does, it adds up the sum between a and b, reaching the function. So in this way, you won't get an overestimation or underestimation. Therefore, integration, or an integral, is expressed using this notation. And the little squiggly line that you see in front of the fx, that is essentially an elongated or a stretched s. It just means the sum of. And since we've got a defined region, it will be between b and a. So this is a definite integral. We know from a previous video that if we have an equation y equals x to the n, then its differential would be nx to the n minus 1. Since integration is the inverse of differentiation, we can look at this and we can find the expression that we need to use if we had to integrate an expression of x to the n. I'm going to write out nx to the n minus 1 out again. If we want to get back to x to the n, basically reverse the process. To get back to the power n, we need to add 1 to the power. And to get rid of the factor n in front of the x, we need to divide by n. And that should get us back to x to the n. What I will do now is I'm going to express n minus 1 as m. Therefore, n would be m plus 1. If I use these and substitute it into the expression next to it, then x to the m plus 1 and n would be m plus 1. So this is the integral when you have x to the m. Now I'll show you a few more integrals of some elementary functions that you should know, or that I recommend that you should learn. On the left hand side, we've got some elementary integrals. What we've just done is x to the n, and as we now know, the integral of x to the n is x to the n plus 1 over n plus 1. If we have 1 over x, then the integral of 1 over x is ln x. And if we have e to the x, the integral of e to the x is e to the x, just like in differentiation. Its differentiation is also e to the x, so the function e to the x doesn't change. Now if we look at the right hand side of our screen, we've got the trig functions. We saw in our previous video, Introduction to Derivatives, that we can draw this circle to remember how the trig functions differentiate. We can use this same circle to also figure out how they integrate. You just reverse the arrows. So sine will integrate to minus cos. Minus cos will integrate to minus sine. Minus sine will integrate to cos, and cos will integrate to sine. So this circle is doubly useful in that respect. So that's it for today. It's only a short video, it's just really a quick introductory video to integration. If you found it helpful, please like and do subscribe, and let me know if there's any videos that you would like me to do or cover in the future. Thank you for watching and have a good day.